Hello friends, welcome to the channel Sky's the Limit. In this video we are going to discuss the topic of physics under the chapter of units and measurement, that is physical quantities. So what are physical quantities? Any quantities which can be measured and can be expressed in terms of numerical values is called physical quantities. Let us consider length. So you can measure length, right? You can say the height of the boy is 5 feet. If you say if you can measure it and you can express in terms of numericals, since 5 is numerical, right? This is numerical and you have measured it. So any quantity which can be measured and can be expressed in terms of numerical values is called as the physical quantities. Another example, you can take time. So you can say the time by your watch is now 5 p.m. okay. If it is 5 p.m., you have measured it. You have measured the time to be 5 p.m. and you have measured and you are writing it in terms of numerical. So this is the physical quantity. Any quantity which can be measured or can be expressed in numerical values are called physical quantities. So here the first important concept you get is the fundamental units. Fundamental units. So what are fundamental units? Fundamental units are the one which are independent of each other. So they are not dependent on any other factor. For example, you can take the example of meter. Okay, meter is the unit of length, right? And you have kilogram. Kilogram is the unit of mass, and time, that is second, is the unit for time. So as you can see here, meter, kilogram and second, they are independent of any other units. And you have temperature, that is Kelvin. Kelvin is also independent of any other unit. Okay, so you have per mole. So all these are the fundamental units. Fundamental units will be clear once you understand what are derived units. So we have next derived units. So what is derived unit? Suppose any physical quantity which is the combination of fundamental units, okay, which is the combination of fundamental units. When I say that, the definition of derived unit is physical quantity which can be expressed in terms of fundamental quantities. Okay, they are not independent, they are dependent on the fundamental units. For example, you can take the example of volume. What is a unit for volume? It is meter cube, right? It is meter into meter will give you meter cube. So you can see here, meter is a fundamental unit. Individually, meter is a fundamental unit. And if you want to find the formula for volume, you need to combine the fundamental units, that is meter, 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 so that you get the formula for the volume, that is unit for the volume. So therefore we called the unit for volume is the derived unit. Another example you can consider for velocity. Suppose you have velocity and the unit for velocity is meter per second. Now see here, since the unit for velocity is meter per second, it is the combination of meter and second. Meter is a fundamental unit and second is also the fundamental unit, right? So therefore velocity, the formula for velocity or the unit for velocity is the combination of fundamental quantities. Hope you understood. Another example we can take of acceleration. What is acceleration? It is velocity by time. That is, unit for velocity is meter per second divided by time. Unit for time is second, right? So therefore you can write it as meter per second. If it moves up, it will give you per second, or therefore meter per second square. You can add the powers if the bases are same. This is one of the property of exponents. So therefore if the bases are same, you can add the powers. So therefore you will get meter per second square. So here also it is clearly evident that the unit for the acceleration is the derived unit, means it has been derived with the help of fundamental quantities, that is the unit meter and the second will combine together and will give you the acceleration. Hope you have understood what are fundamental units and what are derived units. So fundamental units are the one which are independent of any other physical quantities. For example, you have meter, kilogram, then second you have, then temperature, that is Kelvin, you have candela, you have, there are so many fundamental units which are independent of any other physical quantities, whereas derived units are the one which depends on the fundamental quantities. Hope you understand. With the help of fundamental units, we derive the units for any other physical quantities. Okay, so therefore certain derived unit are expressed by mean of SI units, okay, of a special name of a scientist such as joule. So joule, how we write? When you write joule, you have to always write it with a small letter. Okay, when you are writing the unit which is based on the scientist name, you have to always write with the small letter, okay, small alphabet. And when you denote it, you have to denote it with the capital J. Okay, similarly Newton. Newton is the SI unit for force, right? You write it as Newton, that is small n at the beginning, and when you write individually unit, you write it as capital N. Similarly watt, we have watt is W, sorry, this should be small, so therefore WATT, watt. This is the unit for power. Then we have Pascal, which is unit for pressure. We have Hertz, which is unit for frequency. So this is our Hertz. So this question was asked in last GPSTR exam. What is the unit for frequency? It is clearly Hertz. So they can ask for pressure, that is Pascal. Pascal is the unit for pressure. Then watt is a unit for power. Hope you have understood what are fundamental and derived unit. You need to understand one more thing. There are three system of units. Okay, how many systems of units do we have? We have three systems of unit. I'm just explaining it in brief. So just see here, we have three system. Okay, it's better I'll take a new page and I'll try to explain. We have systems of unit. This is very basic. Though it is very basic, it is very important. See here, we have system of unit. We have FPS system, we have CGS system, then we have MKS system. Okay, you need to remember this: FPS, CGS and MKS. Suppose you are measuring length, you are measuring mass, or you are measuring time. Okay, when it is FPS, F stand for foot. Okay, that is feet we say, right? And P stands for pound, that is LB. LB is measure like pound, we write it is in terms of LB. And then we have seconds, that is S. CGS in C stands for centimeter, and G stands for gram, and S stands for again second. In MKS system, M stands for meter, K stands for kilogram, and S stands for second. Okay, hope you have understood the three systems of units used in different countries. Okay, that is CGS, FPS and MKS. So it, like in different countries, they used to measure in different system. Like many countries use the FPS system, some countries use the CGS system, MKS system. So since it was difficult to whenever you move from one country to other country, when you see the units in certain FPS or CGS, it was very difficult for the people to identify the units. So therefore, in order to remove that problem, the system of units, that is internationally accepted system, was introduced, which is the MKS system. So MKS system is also known as SI unit. Okay, that is also known as SI system. This is very important. They can ask you out of FPS, CGS and MKS, which is known as SI system. Okay, so the system of units internationally accepted at present for measurement is the International System of Units, which is abbreviated as SI. Okay, so this SI system is widely used throughout the world. Okay, hope you have understood. So there are 7 fundamental units. So the 7 fundamental units we have: length, mass, time, electric current. I'll be providing you with this chart. Okay, you need to remember or by heart this chart, that electric current we have, then we have temperature, then we have amount of substance, then we have luminous intensity. In the first PU exam, this luminous intensity unit, okay, luminous intensity unit is widely asked. So this is as per the syllabus of first PUC. If you know, this is the chapter 2 of first PUC, okay, that is units and measurement. So here, length, in order to measure length, the SI, in terms of SI unit, it is meter, abbreviated as M, and we have kilogram, which is abbreviated as kg, then second, abbreviated as S, then we have ampere, Kelvin, mole, that is MOL, and then we have candela. This is the unit, SI unit for luminous intensity. Hope you have understood. You need to know the abbreviation very properly. Okay, ampere is denoted as M and Kelvin is capital K. So always in the upcoming videos, in my next video, we shall be discussing about the dimensions. In order to understand dimensions, you need to know what are the SI unit for particular system. Okay, physical quantity, for particular physical quantity, what is the SI system, you need to know about it. Okay, once you know the SI system for the fundamental units, it is very easy to solve the problems or numericals related to dimensions. Dimension is also a very interesting topic, though it seems to be difficult, but I'll tell you, it is very interesting and a scoring subject. So you can also refer my videos for the dimensions. Hope you have understood what is SI system. We represent SI system. There are 7 fundamental SI system. Okay, fundamental units. So this is the and there is, in addition to this, okay, there are 2 supplementary units. This is also important. We have 2 supplementary units, which are those: we have angle in plane and we have angle in space, that is also known as solid angle. Okay, so we have angle in plane. Angle in plane is a unit will be like d theta will be equal to distance, that is ds by r, and unit for angle in plane is radian, or you can abbreviate it as rad. Okay, and the angle in space, which is solid angle, also we represent it as d omega, that is dA by r, and its unit is teradian. It's very important. It can be asked in the objective, what is the unit for angle in plane, that is teradian, which is abbreviated as SR. Hope you have understood. Maybe you know it very basic. Angle is like, suppose you have this line A and this is line B. So this is the normal angle, that is the plane angle. What is the difference between plane angle and angle in space? Suppose you have a cone, okay, and the whole angle here, like this angle, that is the angle of space, we can say. This is the angle in space and this is the angle in plane. This is d omega and this is your d theta. Very small angles they are. So hope you have understood what are physical quantities. So quick summary, we have what are physical quantities, then we have fundamental units, derived units, then the system of units. Okay, and the internationally accepted system of unit is SI unit. Hope you have understood the first topic of physics. Stay tuned with me for the upcoming videos. Hope it will be very beneficial for the one who are preparing for GPSTR and hstr examination. Thank you friends. If you have not subscribed to my channel, please subscribe to my channel and share with your friends. Help them to gain knowledge, and then you can also like the video if you have liked my teaching. Thank you friends.